Well, I will begin with a word of prayer. Ahem. Ahem. Whoa, it's bright. Dear Heavenly Father, we thank you for this day and for a projector that works. Help us to glorify you, what we do, and just help us to resolve any questions before the test, Lord. In your name I pray. Amen. Whew. Yowzers. That's really, really bright. Oh man, I think I left my laser back at the office. Oh well, I'll have to make do. All right, so any questions about anything before I get started? This is your day. You can ask questions all you want. I mean, you can ask questions every day, it's true. But today especially, yep.
I wasn't quarantined when this was going on, so I couldn't take it.
Ah, yes, so we add weight to your test one then. Yep. These things will happen. Unfortunately, once I post the solution, it's kind of over. So similar comments apply to the test. So general point of order, if you take the assignment at the time you can, then great. If not, I will usually add weight to other assignments. So anyway, here we go. Any questions about these problems? D? So here D, oh yeah, I forgot about this. So it's not this, right? It's that thing that's wobbling. So you know what's above here? I think it's the gazebo on the top. So if there's anybody walking up there, it doesn't take much. It just starts the roof wiggling a little bit, and then this happens. So it's also why there are these leaks in this room. Like they decided to put the gazebo on the thing after we built all of this, and they never had proper drainage, which means it will always leak. There's no way to fix it. These have been here for like a decade. All right, anyway. So you were asking about number D? Letter D. So the way to look at it is difference of squares. So 4w squared is 2 times w squared. 9 is 3 squared. So I can factor like that. So whenever you see two things, just if you're trying to factor just two things, always think about completing the square as a I'm not completing the square, rather difference of squares as a potential way to do it, right? So so much of what we've done factoring has really come back to this formula, right? A squared minus b squared is a plus b times a minus b. So yeah, in terms of grading, guys, I put 40 points on the quiz, but you actually only need 30 for the, to get 100 in terms of the syllabus, so there's 10 bonus points. Also, since I came late to this section, I graded the other sections, I found their average, and then I curved your class. So I did curve this test. Somebody asked me if I curved it or not. I did curve so the number you have on the paper, the actual number in Canvas is 3 points higher because I found out that like there's another section that had an average of 22. You guys had an average of like 19.3, so I curved it 3 points. That's generous. There are other sections that had an average of 20, so I could have just curved it 1 logically, but I thought, well, just to be err on the side of caution, curved it 3. Anyway, so there's that. So I will say this, a 20 on this quiz does not really, I mean, you need to do better on the test, right? Because that would, if you just get 50% of the problems on the test right, it's not going to give you a very good score, right? You want to do better than that, but yep.
Do you typically have bonus questions like this on all of the quizzes and tests or no?
On all the quizzes, yes. On the test, less so. On the test, I'll probably have like, I forget what the number is on the test in here. Hypothetically, if it was 150, I might have 160 points. So I usually have a little bit of bonus on the test, but not, I have more bonus on the quiz percentage in comparison, like percentage-wise, if I could use my words here. Yeah. So let's skip ahead here and talk about some of the problems. So this is well, let me go back here for a second. Any questions about this factoring? So if you didn't get the factoring right, what you need to do is you need to go to the textbook, right? Go to the section with factoring and work all of the problems. That would be the smart thing to do, right? There are answers to all of the odd questions in the back of the book, so you can check, right? It is an electronic book, but it still does have answers in the back. Let's see here. That would be what I would do if I was in your spot. Alternatively, obviously work the other quiz. Whatever. If you took quiz A, try quiz B. It's got slightly different problems, so that helps. Here, basically the thing was to factor out the -1 up here. So then these match, and then I cancel them, and that leaves me -7 over t plus 8 for this one.
Why did the 7 become negative?
Because I factor. Yeah, because I flipped the 2 minus t to a t minus 2. Yeah. This one here, I made a common denominator of x times x minus 2, which gave me, as it turns out, 4x minus 2 over x times x minus 2. Which you could factor like that, but I counted this right too. I mean, let's look at the other version of the quiz. Here, version B, these were your factoring problems. I talked a little bit about this Friday already, right? That kind of problem. This one here, you really just need to sort through it. So like, pretty much you're going to want a 5x and an x there. Now, if that all blows up in your face, of course, you can fall back on completing the square and still work it out, right? In principle. Would you like to see how to do this one with completing the square? I can do that. I think that the way it's done there is probably the easiest way, right? But if I was to complete the square on this one, I could, if I'm stuck on the factoring. 5x squared plus 14x. All right. So the first thing I'm going to do is factor a 5 out. So I factor a 5 out. And then I'm going to take half of this. What's half of 14/5? It's 7/5. I square that. I have to subtract the square of 7/5, which is 49 over 25. How many fifths is 8/5? Multiply by, how many 25ths is 8/5? Multiply by 5 over 5. That gives you 40 25ths. And so what we have is 5 times x plus 7/5 minus apparently 9 over 25, right? But what is 9 25ths? It is 3/5 squared, right? So I can look at this as the difference of squares, right? And I can fall back on my difference of squares formula once more. So here I'm identifying. Oh, I'm sorry. Did you pan over here?
Oh,
My bad. I should.
sorry.
It's okay. I was thinking I would be up here, but I realized I wanted to say something here. So think of this as, it's all good. This is a, this is a, this is b, right? So what you're looking at here is a squared minus b squared, right? And so that factors into a plus b, a minus b, yeah? That's the pattern, right? Completing the square, if when you complete the square, you get something negative outside the square, you can always rewrite it as a plus b times a minus b. If on the other hand, when you complete the square, it's positive, what's that mean? If when you complete the square and you have things out here and they're positive, that just means it's prime. you're done already. You couldn't be factored, right? But this one can. And here it is. So what we got? We've got 5 times x plus, what's 10/5? Oh, 10/5 is 2, right? And over here we have x times what? 7 minus 3 is 4/5, right? So plus 4/5. And so there you go. That is an equivalent form of the answer, which I have up here, right? I've just factored 5 out of that factor. Do you see it? What's the difference between what I have on this board over on the left and what I have in my answer in the solution key? Which is easier? Which takes less work? I mean, obviously this takes less work, right? Because this is more clever. But completing the square is an algorithm. It's something you can do. You can factor any quadratic with completing the square. You just have to learn the algorithm. Then you can do all of them. You have to be careful with the arithmetic. So that's hard, right? So that's the challenge, arithmetic-wise. But anyway, let me move on here. This one is, so, you know, I put 7x, and then think about 16. 1 times 16, or 2 times 8, or 4 times 4. And then like 4 times 4 seems like a good choice, obviously, because you get 28 plus 28, which is, well, there's both minus. You get minus 56, and so we factored it, right? Again, if you didn't see that, you could complete the square to find it. Alternatively, you could even use the quadratic formula, find the solutions, and work backwards from there, right? I haven't emphasized that method yet. When we talk about the factor theorem later in the course, I'll talk more about that. But anyway, any questions about these? This one is the sum of the cubes formula. So anytime you've got like a cube plus something, you're probably needing to use the sum of cubes formula, right? If you've got a cubic where you don't have just 2 terms, but you've got like 4 terms for us in here, that probably means it's a, you know, a factor by grouping problem like here. All right, I will move along here. Here's the rational. So these ones are rather different. If you had A or B, like the part A, 2A for some of you was very different than this, right? But here's what it looked like on version B. I had the division of this by that. And so to divide, we multiply by the reciprocal. And then 6 over 9 is 2 over 3. And 11 over y to the 11th over y to the 4th is y to the 7th. So there's that. This one, again, made a common denominator, clean things up. Any questions? All right. All right, so I think this is version A, problem 3. Let's see here. So factor by completing the square. Almost all of you got this wrong. So you know, it's something I'd like for you to fix. This will be a part of the test, and I do want you to learn this. So to factor by completing the square, I made it easy on you in the sense that this one had an x squared, right? Like the thing I have on the sideboard over here was more annoying because of this stupid 5, right? This 5 made this problem a pain. This problem was easier. There was no 5 to factor out, right? So I just took half of the 10, which is 5. I square that, and then I always have to subtract the square of whatever I put here. So 5 squared is 25, so subtract 25. That gives me minus 29. And again, I'm back to completing the difference of squares formula, right? So think of 29 as the square root of 29 squared. And that's it. Should we work another one together? Maybe? Let's do that. So here, you guys try this one. X squared plus 26x minus 7. All right? I want you to factor this by completing the square. All right. And let me add a parenthetical comment there, if possible. If not, say it's prime. All right? So this will be our first one. Our second one, I'll put x squared plus, let's say 100x. Oh, that's too big. X squared plus 20x plus, I don't know, 144. All right. Again, let's factor by completing square if possible. All right. And to make this one a little bit more annoying, I'm going to put a 2 in front of the x squared. All right, so let's do the first one. What do you want? What do we do? Plus what? X plus what? What'd you say? I just missed it. So plus 13, right? Now, if I do that, to be fair, I have to subtract the square of 13, which is 169. So minus 13 squared, which is 169. These two terms are exactly those two terms. I still have to subtract 7, right? So looks like this one factors because the net result outside the square is negative. So I've got a minus, looks like 176. So let's say the square root of 176 squared. Please tell me 176 isn't something nice. That would be so annoying. I left my calculator. Oh no, I left my calculator home. Oh man. It's okay. I'll ask Google. Square root of 176. Okay, nothing nice. Yep. 13 squared is 169. Yeah, 13 is 26. So we always take half of whatever's here, right? So like, assuming that the coefficient is x, right? Now, if there's something in front of the x, I have to factor that out first, like this one, right? So like this one here, when I complete the square, I take half of that, just like I did over there for the other one. So this one, yeah, half of 26 is 13. Now this is yet again the difference of squares. So I use the difference of squares formula. I got x plus 13 minus the square root of 176, or plus it if you like, times x plus 13 minus the square root of 176. There you go. Factored. All right, so apparently that one does factor. It's just ugly. How about this next one? Does this factor? Try completing the square. So I factored the 2 out. I take x plus 5, right? Because half of 10 is 5. And then to be fair, I have to subtract the square of the number that I added, which in this case was 5. So I subtract 25. All right, so what I have there, those two terms, are exactly identical to the two terms I underline above. It's an identity. And then I still have to add the 72. So what do I got? I've got 2 times x plus 5 squared plus, looks like, what's 25 taken away from 72? 47? So plus 47. So this is prime. In the sense that this cannot be factored over the real numbers. So to factor that, I would need to know complex numbers, which we could do, but I didn't put it on your test, did I? Did I put factoring with complex numbers on your quiz? Search your heart. It didn't happen, right? We did talk about it in class a little bit, but I'm saving that for later. So I didn't test on that yet. What's that? We had solution. Now we had a problem to solve. We had complex numbers, right? The answer could be complex, but I didn't ask you to factor with complex numbers. Here's the difference. X squared plus 1, x plus I is x minus I, right? Versus x squared plus 1, equals to 0, which gives me x squared equals to minus 1, which gives me x is equal to plus or minus square root of minus 1, x equals to plus or minus I. So the factoring problem, this right here, oh, come on. All right, enough. Oh, well. I tried. So this one right here, later. Okay? Later. This right here is a simpler version of one of the problems that was on your quiz. This could happen. Solve x squared plus 1 equal to 0. That's a potential problem. In fact, problem 4 is like that. Did you pan over there? Yeah. Thank you. Well, I'm giving you a workout today. See here, so.
So if you did factor into the complex numbers, would you accept that solution as well, or would you rather stop?
Oh, well, it depends on the. I probably won't take points off if you do that, but technically you wouldn't be following instructions because I said to factor over the reals.
Right.
So if it only factors over the complexes, you should stop. You should say this cannot be factored. This is prime. You had homework on this, right? Like factor if possible. If it's not, mark prime, like that. So this one is prime. So when you complete the square, if after you do the arithmetic, you get the squared term plus a number, that means it's prime. If you get the squared term minus a number, you can always fall back on the difference of squares formula, difference of squares formula to factor it. Those are your two cases. Well, there's a third case. What's the third case? Sometimes you complete the square only to find out that the whole thing is just one square, right? What happens if you complete the square on something like, I'll do it down here. Well, I'll do it over here. If I had something like x squared, plus 26, I'll do the 26x again, plus 169, you do x plus 13 squared minus 169 plus 169. Lo and behold, completing the square revealed, that's just x plus 13 squared. So if you complete the square on something that's a square, it will just factor it, just straight up. Anyway. All right, let me go on. I have said my piece about completing the square. Please learn it if you haven't. I cannot, you can lead a horse to water, but you can't make it think, right? So, so here we have 3x plus 7 squared equals to minus 17. You're asked to find the solutions here, right? This is not a factoring problem. This is an equation, so the answer should be numbers, or perhaps the statement that there are no numbers. And so what I did was I used the square root property. I factored out the minus as the I, and solve for x. This one, I completed the square, right? So x plus 4 squared, I subtract the square of 4, which was 16. That leaves me with a 2 on this side. When I move it to the other side, I get a minus 2. And as such, I get minus 4 plus or minus I root 2. Many of you got this wrong because you used the quadratic formula, and you used the quadratic formula carelessly. So this is why I shy away from teaching you guys quadratic formula, because I have seen that it is almost universally the case that at least 50, 60, 70% of the students, when they try to use the quadratic formula, it falls apart because you don't follow through on the formula. You have to divide both terms by the number. A lot of you just divided the first term by the number, but not the second, or vice versa. That's like why it was wrong. Others of you just didn't finish the formula. I mean, there's so many different ways to do the quadratic formula wrong here. It would be better if you learned to complete the square. Now, if you're going to use the quadratic formula, though, I would like for you to simplify the number, all right? So, like, I am not going to give you full credit if it's a quadratic formula where you haven't finished adding together the number and the square and stuff like that. Like, I will take off points for incomplete, unsimplified quadratic formula. If you're going to use the quadratic formula, you need to complete the thought and leave your answer something like this. I don't usually care too much about simplifying numbers, but on this kind of problem, I actually do care. So let me say that. I will probably change my wording slightly to reflect that reality. Something like, I'll say, for full credit, make sure your answer is simplified. I probably will add that sentence to this problem. By the way, what's your test look like? Something like this, right? Now, is your test going to be this long? No, I'm gonna cut off a page, maybe two, who knows. We'll see what happens. I don't actually think it's the length. I think it doesn't matter how much time you have. If you don't know how to do the problems, you can have all the time in the world. It won't change anything, right? So I mean, I know you say it's time, but let's see about that. Now, I will say this also, if you look like, you know, past eras. By the way, I should mention that. You can see old tests if you look at my website, right? But I don't know how relevant the old, I think the quiz is more relevant than my old tests, probably. This was a homework problem, right? Yeah. In fact, both of the applied problems were like either examples from class or homework problems or both, right? So to do this one, I draw a picture, I label X, I label Y, and I work it out. So let me go on here. Any questions though? So I think this one here, let's see, I'm trying to remember. So here's an example of one where, you know, maybe the quadratic formula is a reasonable choice, right? Because like completing the square is kind of a pain here. So if I was going to use the quadratic formula on something, it'd probably be this one. You see what completing the square does, by the way? Do you see what it does? So for an ugly problem like this, I mean, it looks ugly. Actually, the answers aren't ugly, are they? But the calculation is ugly. It's kind of funny like that, right? But these formulas you're getting out here, if you really tilt your head and squint at them long enough, you'll see that this is exactly the quadratic formula. So that completing the square for a problem derives the quadratic formula. But it does it in steps which are easier in terms of the arithmetic often than actually just directly using quadratic formula. All right, enough. I'll get off my soapbox here. So here's yet another version B, completing the square. Any questions about that? Let me not talk about that. We talked about that a lot already today. So this one, again, square root property. What's the difference between like this and the other version? This one had plus, right? The other one had minus. So the one that had the square is equal to a minus gave me a complex number answer, right? This one here, we just have a plus 36. So I take the square root of both sides. I get plus or minus square root of 36, which is plus minus 6. I divide by 2, and I get 0 or minus 6. This one here, I completed the square, and I found that. All right? So problem 5, I have given you, many of you got credit for this without doing a lick of algebra. You just gave me a sentence analyzing like possible factors of 24, and I had to look at it and go, dang it, that is a solution. I can't take points off for that. It's not what I wanted, but you're not wrong, right? So there's a lot of you got credit for this problem, but you didn't do it in the way you're supposed to.
What is successive integers?
Successive integers, like
Just like actual numbers?
they're not like so 4 and 5, 3 and 4, 1 and 2. The number that comes right after the other. So so x times x plus 1 is, but there was a homework problem like this. Anyway, so it gives me a quadratic formula. I solve it. The answers are not whole numbers, so they're not integers. It's not possible. But you guys gave non-algebraic, number theory-based answers I could not count wrong. So I would say that casts a kind of long shadow for this being on the test, because it's hard for me to test algebra with this question, actually. So I'm just kind of telling you it's not on the test. But rarely will you hear the words escape my mouth, this is not on the test. But this is not on the test. All right, so here, all right, so there is a popular mistake I need to address. It's always popular. So a lot of you did something like that one. You did something like this. Your first step was this: x squared minus 15 minus 2x. Maybe you put some parentheses even, let's be generous, equal to 0. So you went from what was there to this down here. Can you guys tell me what's wrong with that? What's the idea behind writing what I just wrote? I gotta zoom out a bit. What's wrong with, why can't I just say, well, okay, so x squared minus the square root of, the square root of 15 minus 2x squared is 15 minus 2x, right? Well, it does have parentheses, but yeah, you might have, some of you guys might have even dropped that, yeah. But there's a bigger problem here. When we've got two things, right? If I have a minus b, this pattern, and I square it, what happens? I get a squared minus 2ab plus b squared. So you can't just, when you have a difference of things, you can't just square each term individually on its lonesome. That's not how it works. Right? You have to, like, if you have two things added together, when you square it, you have to multiply it out. So that's why I don't square the original equation. I first isolate the radical. Right? Step number 1, isolate the radical. You must isolate radical. So that's what I do. So this is bad algebra right here. Okay, this is not true for that problem. So we isolate the radical, and when I do that, then I square. I get rid of the radical, right? I get x squared equals that. I put it all on one side. It gives me a quadratic. Thankfully, this one's nice. It factors, right? Usually, a problem like this is going to be nice. So like the quadratic isn't also going to be ugly. If the quadratic is also ugly, it either means I made a typo making the test, or you made a typo in your solution, probably. I'm not saying which one is more likely, but anyway. I expect the quadratic you get from one of these problems to be one you can factor, okay? Just as a general point of how these problems go when they're taken from textbooks. Anyway, so I factor, I get minus 5 or 3 as my solutions. But this kind of problem, whenever you square the equation, you have to be leery that maybe you've added an equation, a solution, which is not really a solution, right? A so-called extraneous solution. That is the case here, because if you check, when we try minus 5, it doesn't work. It gives us minus 10, which is not equal to 0 when we plug it into the equation. So in fact, only 3 is the legitimate solution here. So technically, the solution set is 3. Now, if you wrote down x equals 3 as your solution, I did not take off points. All right? So the reason sometimes I use the solution set language is so that when there is no solution, you can write down empty set and you're not confused by the wording. This one here, we've got 1/3 power equals minus 2. So the natural enemy of the 1/3 power is the cube. Cube both sides. You get this quadratic. You factor it. You solve it. You get 2 or 4. And both of these work. When you cube an equation, you don't lose or gain solutions. So even powers are funny. They squash minuses. But odd powers don't change solution sets. So I knew I didn't need to check these. They would work. In contrast to like part A. C, so to get absolute value equal to 2, you can either have it equal to minus 2 or 2, right? And that's possible because 2 is positive. So we get either minus a half or minus 5 halves. Some of you have that written down, but it was counted wrong. Why is that? Because you have the other version of the quiz, right? Other version of the quiz. We'll get to that in a second here. Actually, let me skip ahead to the other version. We'll come back to the inequality here. The other version, first of all, the part A is rather different. So if you make sure you work both versions of the quiz for yourself. But let's focus on part C here for just a moment. The other version, you had equal minus 2. What's the solution to absolute value equal to minus 2? You don't need to do math. You just need to use common sense here and go, wait a minute. Absolute value can't equal negative. End of story. No need to do more calculation. No solution. If we have absolute value less than 0, or if we have absolute value equals to negative, both of those problems, the answer is no solution. Because we can't have absolute value negative. So let me go back to the previous version. Actually, let me finish talking about this one here first. So the top one, I multiply by x minus 6. Again, you get a quadratic formula. This factoring here wasn't obvious to me at the start. Like I had to think about that. This was like, I think this was the hardest factoring problem that works out nicely on this test was this, without a doubt, in my taste. So anyway, if you got to the quadratic formula but couldn't solve it, it's understandable, but you really should not leave any like opening in your defenses on this test for a quadratic equation. There is no quadratic equation you should not be able to solve, right? Because all of them can be solved either by what? By factoring, right? That's the easy way, if it's possible. By completing the square, right? Using the square root property. Or the quadratic formula. Careful calculation of the quadratic formula, right? That gets every possible quadratic equation. There is none of these you cannot solve. I can't often say that in math. Like there's a problem which is always solvable and the solution's like nice, but that's the case with the quadratic formula. So quadratic equation rather. This one here, again, isolate the radical. Step number 1, isolate the radical. So I isolate the square root of 2x by adding x and subtracting 4 to the other side. Then I square it to get rid of the radical. That gives me 2x equals to this. When I square that, it's not just x squared plus 4 squared, right? It's x squared minus 8x plus 16. There's this middle term. Don't forget the middle term. When you're squaring a sum of two things, you should have 3 things once you collect like terms, right? Usually. And then this gives us this quadratic, which can be factored. So my solutions are 2 or 8. But again, one of those we have to throw out because it didn't work, right? Which was the 2 doesn't actually solve the original problem, so I have to throw it out. My solution set's 8. All right, so I spent quite a bit of time talking about the number line problems. Many of you still haven't learned it. You need to learn it. If you don't know that, you're leaving yourself wide open for like losing a lot of points on the test, right? So it's important to understand how to do these problems. So there's A here. I'll walk through it again. So this one, the critical numbers are where this or this or this are 0. In this case, minus 7. Minus 1 makes that 0, right? 5/4 makes this 0. I think some of you put the numbers out of order on the number line. That'll mess you up, right? Anyway, I plug in some points. So here's a general observation. If the coefficients of x are all positive, then that means that if you make x big enough, it's going to be positive to the very right. So like if you think about putting in like, I don't know, 1,000, this is going to be 1,000, 3,000, 4,000, right? So you multiply those, it's positive, right? So I start out positive, then I flip signs each time because these are odd powers, power 1. So I flip the sign each time. So pluses, minuses, pluses, minuses. I'm solving less than or equal to 0. So I'm looking for the minuses. So I go minus infinity to minus 7. I include it because I'm looking for 0. And then minus 1 to 5/4 like that. That's the solution set. And this is a union. So there are people who got this problem right. All right. There's about, I don't know, 20% of the class got this right. Maybe, I forget the exact statistics. Some people have got this problem right, but there's a lot of you who got this problem really wrong. And you need to work on it. So this one here, this is less than, so we can unfold it. Minus 2 less than 6 minus x less than 2. A lot of you made this problem way harder than this. You've got like a paragraph worth of stuff. I don't know what you're doing, but you don't need to do it that way. Yeah. I forgot to tell you guys to bring Dramamine to the review session. But so then you multiply by minus 1. It flips the inequalities. And so 4 to 8 is the solution there. Let's look at the other problem. Any questions? We did many examples of the nonlinear inequality, right? I spent probably an hour of class. I spent a long time on that. This one here, greater than or equal to, you either do less than minus 2 or greater than 2, and it works out to either this or that. Let me go back here. this one here, let's talk about this one here. So again, the critical numbers -7, 6, 3, and -1, you put them on the number line. You test, I plug in 0, for example. I've got 7, 36, -27, 1. So I've got plus, plus, minus, plus, which is a minus between -1 and 3. So that's negative. Since x plus 1 is a square, I don't flip the sign. Since -7 is x plus 7, that's a linear term, so I flip the sign because it's an odd power of 1. At 6, I don't flip the sign because it's an x minus 6 squared. But at 3, I do flip the sign because it's to the power 3. So it gives me this sign chart. I'm solving less than or equal to 0, so I look for the minuses, right? And so I've got -7 to -1, union -1 to 3. Why don't I include -1? Because denominator, division by 0. I can't include -1, right? So I got to omit the -1. But since I'm solving equals to 0, I also have to throw in 6, because plugging 6 in does make the 0. Now, if you had this, but you just didn't union the 6, I gave you a lot of partial credit, all right? Like, I didn't take off that much, comparatively speaking. But this one here, less than -4. Answer, done, can't do it. Can't have absolute value negative. Solution is nothing. There are the empty sets of solution there. Let us conclude by looking at the graphs. So I asked you to leave your answers in interval notation. It's important that you do that. Some of you have given me this list of numbers. I don't know what to do with that. Interval notation, must use interval notation. F of 2 is -6 because that's where the dot is. Minus f of 2 is -6. It's understandable you guys didn't get problem 11 right because you probably hadn't worked the homework yet. That's all good. Hopefully you'll get a problem like that correct on the test. But anyway, I'll see you guys Wednesday. Thank you. If you think I graded something wrong, you can let me know about it.